In our previous session, we have completed studying a LT log that has been collected on MME. In this log, we have observed that a mobile equipment successfully got attached with the LTE network, and also subsequently it got detached from the LTE network. Both parts happened in the same log file. So now we are going to go further ahead and study much more many logs. Okay, so the next log file that we are going to hit is this. So we have a we have outbound message. It starts with the device watchdog mechanism as usual. So we can ignore the device watchdog parts because we know what is the purpose of it already, and we know the AVPs. It is going to be repeating the topic. So what is this new log file is about? This new log file is about doing an attach procedure for the mobile along with the default bearer. And along with the default bearer, we are also going to have a dedicated bearer as well. So we are going to see one additional dedicated bearer creation for the mobile after the mobile equipment completes the attach procedure along with the default bearer. Okay, so what it starts with? It is usual starting with inbound S1 AP, initiating message, S1 setup, it's starting from. So S1 setup is a communication mechanism between eNode B and MME. As usual, it will contain 4 IEs, global eNode B global ID, eNode B name we have, and we have supported tracking areas, something called broadcast PLMNs and etc. supported tracking areas. Then we have default paging DRX. So the value of that is this version 32. We have these 4 things that are present. So eNode B is proposing S1 setup. So from this, what can we understand is one very important thing. All these log files that I'm showing you are captured on a test environment. That means at the time when you are performing a proper testing. So in a test environment, all these things are collected. Okay, so what is the linking point that I have to convey? In every test environment, at the starting, nothing will be there. That means even eNode B to MME connection also won't be there at the starting. So you have to establish it. That means at the end of the test case, in the first test case, for example, all the environment will be brought back to the normal state by removing all the things that have been created. So then at the time when you are establishing a new test case, when you are trying to create a new test case, you have to go back again. You have to go back again and create everything afresh. But in a real environment, it won't be like that. In a real environment, eNode B would be connected to MME only one time in its lifetime, until unless there is a reset taking place or something like that. This S1 setup procedure will get executed exactly one time only. From eNode B to MME, MME would set a successful reply back outbound S1 AP, successful outcome for this S1 setup procedure. MME quotes its own name, what are its GUMI IDs, And what is the served group ID, MME code, and what is the relative MME capacity? The details are same. Actually, there is no need for eNode B and MME have to exchange the same information again and again for every single mobile phone. It is not needed. This is not a mobile specific message. Um, it is basically a global procedure on S1AP protocol. It is global. So because it is a global procedure, you definitely need to um, exchange it only when it is needed, not because a new mobile equipment is coming up and a new mobile equipment is wanted to make an attach. That time we must make um, a S1 setup immediately. It is not like that. Okay. So after the S1 setup is completed, you have the inbound initial UE message, the first UE message we are getting. UE, be UE S1 API ID, we have NAS PDU. So initial UE message brings you the NAS message. So there is a NAS PDU arriving in, and this is the full NAS PDU. If you decode that NAS message, it is a attach request, and it is at EMM level, it is a attach request, and at ESM level, EPS session management level, it is PDN connectivity request. So as usual, mobile equipment is sending its initial UE message, and of course, eNodeB is reporting mobile's present tracking area code, mobile's present cell ID, and what is the establishment cause RRC has quoted at the time of establishing the connection. Any MME preference is there or not? GMMA ID mobile quoted. So these details are being forwarded to MME. So when mobile requests for a attach procedure, the steps are going to be almost similar to whatever the steps that we have discussed in attach with default bearer log file, the previous log file. Not even one single difference would be there. MME now communicates with HSS first, gathers what once he gets this NAS message separately received it. So then MME starts sending out authentication information request for getting the authentication parameters from the HSS on 3GPP 6A. If you want explanation for this message, um, you have to be dependent on this log file itself. In this log file, we have studied each and every message for quite some time. You have to be dependent on it. I won't be explaining the same messages once again, which contains the same contents, but I will show you important what are the messages in the order once again. So first we send authentication information request outbound towards HSS, asking the authentication details for this particular user name for this INSI number. And obviously, once we request an immediate response preferred, number of vectors you are requesting is only one requested UTRAN authentication information. And mobile equipment visited PLM and ID is this, it is decoded, but anyway, it is the PLM and ID, and you are telling requesting node type is MME. Once we quote all these details, what reply you get back in the inbound is authentication information answer. So in authentication information answer, we are going to have what? Um, we are going to have um, the most important details that will be part of it is it explains that result code is success, diameter success, and then the actual information we have requested for that starts here, authentication information, and we have in the authentication information uh, ultra vector. Number of items we have is only one with this number, which contains a package of random number XRES, authentication token, and KASME. These are the four things that we are going to have: random number XRES, authentication token, and KASME. Then we have the Jaran vector, which is nothing actually not needed, but it is sent. But it's fine. Actually, we needed ultra vector. It could be blank. This Jaran vector is simply a blank thing. We can leave that Jaran vector part. So once we get that authentication information, MME prepares a NAS message uh, called as authentication request, sending random number and authentication token to the mobile to challenge it. So what is that we are going to see in this NAS? So in NAS, what do we do? Uh, NAS would contain the NAS would contain the uh, logic of challenging the mobile, whereas we have to send the NAS message by packing it into S1AP message. We cannot independently send it. So the NAS message is going to be packed into S1AP downlink NAS transport, and it would be containing the MMEU S1AP ID, InnodeBU S1AP ID, followed by the NAS video itself, which is authentication request by sending random number and authentication token. Of course, ENODB extracts this NAS message and send it to the mobile and RFC protocol. Mobile prepares the response and it sends back that response to ENODB. ENODB is now going to send that response to MME in the form of uplink NAS transport. It sends the message. How many IEs would be there is 5 IEs. Yesterday also we have learned this concept. Every time there is a NAS message arriving from ENODB to MME, totally there would be 5 IEs present. 2 IEs are representing the IDs, MMEU ES1 API ID, ENODB ES1 API ID, followed by the NAS video itself, which is the authentication response, basically. So if you look at it, so I think we have moved a little far. Actually, some steps are missing, I guess, here in this log file. Okay, anyhow, some steps are missing in this log file. So seems like the log is little wrong that from that point of view. So basically, we need to have first authentication response received, then we send the security mode command, then we are going to receive security mode complete. So that is how it has to happen. But directly we have got skipped up to that. Okay, I think we have skipped up, not there. So there is a NAS video arrived right now, which is authentication response. That is the response message received. Once we separate that NAS message and study, and MME will validate this response against HSS response. If both are equal, mobile equipment is found out to be genuine. So then what you are supposed to do? Then you would be performing this activity outbound. Um, so NAS message you are going to send a security mode command to the mobile, ask the mobile equipment to start ciphering and integrity protection for NAS level by quoting some key set identifier, etc. So once we send this security mode command, again NAS message need to be packed into S1AP, downlink NAS transport, and once the NAS message is sent, um, with the three IEs. Of course, the third IE is going to be this NAS PDU itself. Other than the UEIDs, it is a security mode command. And then once we send it, we are going to receive an inbound uplink NAS transport, uh, which contains, as usual, five IEs, two MME, two IDs, MMEU ES1 API ID and eNode BS1 API ID, followed by the actual NAS PDU that we are requesting for, which is in the encrypted format right now. And then we have the cell ID and tracking area ID. So once we decrypt this NAS message, which is in encrypted format, at NAS level, we need to decrypt it. So we'll understand the NAS message as security mode complete. We understand it as. So mobile has accepted the security mechanism. All right. So what next? We are going to have once mobile accepts this security mechanism. Um, so we are going to request for subscription information by sending update location request towards HSS. So once we send that request message, by quoting the important information as user ID, so username, that is the IMSI number, rest of the details are repetitive. We are going to get a reply back, update location answer. This update location answer contains, um, the result code set to diameter success. Because it is set to diameter success, you will have subscription data that is arriving from HSS. So it contains subscriber status, MSISDN number, network access mode. Only packet services are available. There are no services right now barred for the mobile. 3GPP charging characteristic rule is 1, 2, 3, 4. Then the AMBR that is approved for that mobile, etc., etc. Then it starts this big package, APN configuration profile, which contains APN configurations which we have studied. So from here onwards, it contains the APN configuration with context identifiers, context ID 2. The next one will be context ID 3, context ID 4. This is the same repetitive thing which we have done yesterday. All the context ID 5, context ID 6, context ID 7, 8, 9, and 10, uh, 11, 12, and 13. So mobile subscribed for connecting to 13 PDNs. Once all that information is completed, you will have, one more last information that is present is RAT frequency selection priority. With that, your update location request is completed. Once that is done, as usual, what you have to perform is start sending out um, a message called as um, create session request to ask S gateway and P gateway to create the required tunnels, control plane tunnels as well as user plane tunnels. So outbound, here in this case, DNS messages are not there because we are considering that MME already got to know about the which S gateway services and which P gateway services it has to use. So the DNS part is ignored. That is what we are considering. So then we are directly starting with the create session request itself. Okay. So Create session request will create control plane tunnels and user plane tunnels between S gateway to MME to S gateway to P gateway, etc. So what details would be present here? So we are quoting the IMC number for which we are doing this activity, MSIST, and user is present in which location, and mobile is present in which PLM and connected to which radio access technology network. And MME is quoting its TAD. The TAD it has created to represent this user. Next time onwards, yes, gateway must use this TAD in the header. And in the disguise of giving a P gateway CFTEAD, actually MME forwarding P gateway's IP address details to S gateway. So that is that. And there is the access point name and the mobile equipment want to connect to the PDN connecting point. PDN type is IPv4 and IP address that is available for the mobile for this PDN is 0.0.0, meaning is not available yet. So there are some flags and there are some APN restriction. Nothing is there. Aggregate maximum bitrate 10 kbps, 20 kbps. Some protocol configuration options which we have ignored, and then followed by the bearer context to be created. The bearer need to be created. User plane bearer is 5, and bearer quality of service is nothing. So we have these details present there. Okay. So then we have the recovery parameter, UE time zone, and charging characteristics, etc. We have all these details. So we get an inbound reply back, create session response, and this is the TAD created by MME. Now S gateway is quoting this TAD in the header, and it is reporting that it is accepted the cause request, and even bearer also has been created successfully. So control plane part successful, user plane part successful, and the charging ID has been changed by PCRF. Uh, your TAD is S gateway TAD is 192.60.60.13 with this TAD. This is the IP address and TAD. P gateway IP address and TAD, and the recovery parameter 101, and S gateway's control plane TAD is 192.30.30.10. This is the TAD for control plane on S11 interface. And what is the IP address that is allocated to the mobile equipment is 12.0.0.1, and APM restriction is 0. P gateway's control plane tunnel ID for the handover reasons is 4D5 and 10 to 11 12.13 IP address of P gateway, then followed by the protocol configuration options which we have ignored. So once we get the create session response, we know that control plane tunnels are created, user plane tunnels are created for the default bearer. So now we are preparing a NAS message, which is attach accept, containing the tracking area ID list where mobile is not required to do the tracking area update. These are the adjacent tracking area information, followed by ESM container containing a EPS session management message, asking the mobile equipment's permission to activate the default EPS bearer request, which is getting created with this QCI, with this IP address, and the 3G specific quality of service parameters as well. And finally, the GUTI parameter, the global unique temporary identifier that is allocated to the mobile, which is mobile country code, mobile network code, MME group ID, MME code followed by the MTMC. There is some timer parameter. Okay. So of course, any NAS message which we prepare have to be sent out in the S1 AP. So we are preparing a S1 AP message called initial context setup and asking InnoDB to do the initial context for the mobile. So we have MMEUES1 API ID, InnoDB UES1 API ID, aggregate maximum bit rate. We have which is 20,000 and 10,000 BPS. Then we have ERAB to be set up item. The ERAB that need to be set up is ERAB ID 5. We have and quality of service class identifier is 9. Allocation retention priority. This transport layer address C0 is 192, 3C is 606013, which is S gateway's IP address and S gateway's TEID for receiving the uplink traffic from mobile. And the NAS PDU itself, which is encrypted, sent to the mobile. Then quoting the UE security capabilities that are known to MME, encryption algorithm, integrity algorithm, and the security key, which is nothing but K InnoDB, that is sent to the InnoDB. So then InnoDB does that activity requested. It creates the radio bearer and S1 bearer. After it is successful, it reports back with the inbound initial context setup successful outcome. In this, it is going to send 3 IEs, MMEUES1 API ID, InnoDB UES1 API ID, followed by the ERAB setup request. Which ERAB is talking about? ERAB ID number 5, it is talking about, and you have the IP address of InnoDB and the TEID created by InnoDB to receive the downlink traffic from S gateway. So these tunnel ID details would be forwarded to S gateway basically. Okay, so what next immediately happens after this? So after this, I'm going to have an inbound message. Uplink NAS transport. I'm receiving. Which is sent by the mobile. Of course, InnoDB is always sending 5 IEs. Only one IE is going to be your NAS message. Remaining all the IEs are InnoDB sent information. So 2 IDs followed by the NAS PDU itself, and then which is encrypted format, and then EU trust CGI ID and the tracking area ID where mobile is present under. So if you decrypt the NAS message, we know that the message is attach complete and activate default bearer acceptance. It is once we decrypt it. Okay. So at this stage, we are going to send an outbound towards S gateway. Once, because we got the permission to activate the default bearer, now we can send InnoDB tunnel details to S gateway by sending eGTP modify bearer request. So for this EPS bearer ID 5, InnoDB tunnel ID is yes, it is for S1U interface. InnoDB S1U IP address is 192.10.10.10. On this IP address, we have. Okay, so once we send it, we have inbound modify bearer response. So it is accepted the details and it will reconfirm its own TEID for S1U interface 4D4 192.60.60.13. It is reconfirming its tunnel ID. Done. Once this is completed, we are going to have an outbound message over here. Notify request, notifying HSS that mobile equipment successfully connected to a subscription service called as Starrand.com PDN is connected to this service. We are reporting. Okay, so at this stage, of course, a reply need to be received, but immediate reply is not needed. Reply will be there somewhere later. But at this stage, we know that the mobile equipment attached with the LTE network is completed. So at this exact position, where are we? Whatever the procedure we have studied so far is the same steps as the one that we have studied in the previous log file attached with the default bearer. Now we need to study this extra part. So dedicated bearer. So how the dedicated bearer gets created. That is what we are more interested with in this log file. All right. Um, so we are receiving an inbound message here. Inbound message from where? S11. S11 means it is arriving from S gateway. There is an inbound message. What is it? Create bearer request with this tunnel ID. Actually, who is generating this create bearer request? It is either generated by P gateway or basically create bearer request is obviously generated by P gateway. When does P gateway generates this message? Whenever P gateway identifies the need for identifies the need of creating a dedicated bearer for the mobile, either on his own or PCRF has told him to create a dedicated bearer for the mobile because PCRF learned some information from um, uh, um, from application server. So that time we will be, you know, P gateway will be starting the procedure. So so that's the primary idea. So create a bearer request we are arriving. So we are damn sure about one thing because create bearer request is getting initialized from the P gateway. We know that mobile has no role to play in this. Mobile is not requesting for this dedicated bearer. How are we so sure about mobile has got no interest in this? Um, because if mobile is interested to create a dedicated bearer, we have a procedure that first mobile need to communicate with MME, mobility management entity. Then MME will be communicating with S gateway, S gateway to P gateway. Once it goes to P gateway, then P gateway ask the permission from PCRF to create this bearer, then it actually like start the creation. So then it starts sending this PCRF talking to P gateway, and then P gateway start creation of the dedicated bearer. So we could have seen this communication happen if mobile is interested for his uplink purposes. But right now, I can clearly say that the mobile is not so much interested. It is not uplink data related. It may be downlink data related. Either application server has told this situation to PCRF, or when application server started sending huge amount of data, P gateway himself realized that this much amount of huge data that need to be sent to the mobile cannot be sent on his existing default bearer. So he took the permission from PCRF and he started creating an additional bearer. So that's why it is triggering create bearer request. Actually, P gateway triggers it. First, it comes from P gateway to S gateway, then it comes from S gateway to MME. But in this log file, we can only see the communication happening between S gateway to MME only. We cannot see what is happening between P gateway to PCRF or P gateway to S gateway as we are collecting this log on MME. Just a minute, guys. So yeah, we have we have that. So what is it asking to create in the create bearer request? So this is the most important message with respect to the second log file. EPS bearer ID is already existing. Bearer ID 5, which is the default bearer. There are no changes for that bearer. It is sending a bearer context for EPS bearer ID 6, a new bearer it is proposing. And the bearer TFT, bearer traffic flow template, nothing but the IP addresses and port numbers. So whenever the IP address, whenever the traffic is going to this application server on this destination IP address, then that traffic must be sent on this EPS bearer ID 6. We are identifying that packet flow details, packet flow filter criteria. And for this, already S-Gateway created a tunnel ID, 4D7 on the S1U interface. And the P-Gateway tunnel ID is also being reported on the S5S8 interface, the one that is created by P-Gateway. So it's IP address and it's TE-ID. So this is S-Gateway's IP address and TE-ID. Of course, P-Gateway tunnel details are needed for MME only for the handover scenarios at the time when the S-Gateway is changing. When S-Gateway is not changing, we don't need it. We do not require it. P-Gateway tunnel ID details. Bearer quality of service is QCI4 with very high amount of guaranteed bitrate and the maximum bitrate with QCI4. QCI4 only can be used. QCI4 is only possible to be used for dedicated bearers. Okay. There is a question about what is the user created or application server created dedicated bearer. It is not about any of that. Okay, let me tell you an example. We have the mobile, we have the application server. You are using WhatsApp application and sending, by using WhatsApp application, you are sending small messages. Typically, to send these small messages and to receive the reply from application server from the other person, you just need default bearer that is enough on your WhatsApp application. So even though you are sending the WhatsApp messages and receiving the replies, you don't need a dedicated bearer. We can survive with the default bearer itself. Okay. But suddenly what you did, he has asked you, hey, can you please send me that file? I have lost that file. Can you please send me? He has asked you. The other person has asked you. So now what do? You decide to send that huge file, which is of very big size, like some 17 MB file. You have decided to attach that here and send that file. Now, the moment you do it, now we cannot send the 17 MB file on a default bearer. If we send it on default bearer, it requires ages to send it. Now, about this file, who know? Only your mobile equipment know about this huge amount of data getting generated for uplink direction. So what does mobile do? The moment this huge amount of data getting generated, your mobile's NAS layer sees this situation and say, to send this much amount of data, having default bearer is not enough. I have to send a proposal to MME to request for dedicated bearer. So NAS will send a message to MME. MME in turn will start speaking to S gateway and P gateway, and then the P gateway communicates with the PCRF. Then once he gets the permission from PCRF, P gateway starts creating the dedicated bearer by using the same message. This is this. Because the uplink data got generated. Why nobody knew about this uplink data? Until and unless this uplink data is sent to application server don't know that mobile is generating that much amount of data. After receiving, he will knew it. So application server don't know it. Now, how can P gateway recognize this huge amount of uplink data? It cannot, because if it has to receive this huge amount of uplink data on the radio bearer, S1 bearer, S5, S8 bearer, first the data need to arrive at P gateway. If the data is arriving by using the default bearer, P gateway would be thinking that okay, anyway the data is arriving on default bearer, that means default bearer is enough. You don't know that this data is a huge data, and actually your mobile equipment is in the need of dedicated bearer. He never can understand it, because the data is already arriving on the default bearer to him. So your P gateway cannot realize it, application server cannot realize it, because the data originator is your mobile phone. It is the originating guy. Only mobile can realize it. Okay, other way around. We have sent a big file. This guy recognized it. It is not this scenario we consider. We have asked the other person you are chatting with to send a big file. So that guy sent a 20 MB file. The 20 MB file arrived at WhatsApp application server. He has uplinked it. Now application server started sending a huge amount of that file data, IP packets with huge IP packet sizes. It starts sending it to your P gateway. One after the other, by using this high-speed Ethernet link, it will start sending those packets. Immediately, P gateway realizes that, oh, these many IP packets, this is bad. I cannot send these many IP packets by using the default bearer, which is working with very low amount of quality of service and data rate. So what do I have to do? I have to simply create a dedicated bearer for this amount of traffic. So who recognized it here? P gateway recognized it on the basis of traffic, amount of traffic that is arriving, because it is arriving in the downlink on the on the internet connection from application server to P gateway. Because P gateway is receiving the traffic, P gateway can realize the need for creating a dedicated bearer. So he communicates with PCRF and gets the permission and starts this. Otherwise, application server knew that there is a 20 MB file. He can go and communicate to PCRF by using RX interface and explaining that, hey, I'm about to send a very big file to this particular so-and-so user. I'm reporting it to you. Please communicate with the P gateway and already prepare a dedicated bearer even before I start sending that file data to you, to the P gateway. Please, application server asks PCRF and RX. So PCRF send a push procedure to P gateway to trigger the dedicated bearer creation. So then P gateway triggers the dedicated bearer towards S gateway to MME to T node B, etc. So have you understood all the three scenarios? Still having a doubt?
Yes, sir. I have a little question here. Whenever we talk about the default barrier, is that normal communication happen between the nodes. But if the dedicated comes, it should always the maximum, from the
Higher
default
data rate.
behavior.
Other than whatever the data rate that is already ongoing on the default. Even if it is little higher
So,
than default also, we will try to create a dedicated. Need not be very high data rate also. Anything deviating from the default, we must go for dedicated.
so in that case, we always want to achieve maximum. What I mean to the maximum, more bitrate in the case of dedicated bearer, not less like from the default. Correct?
Correct.
Okay. Thank you.
Anything which is less than default, we don't need dedicated. We can use default itself, because default accepts the data from every application. It is having no restrictions at all. Okay, so proposing a dedicated bearer from P gateway by quoting the TE-IDs, etc., and bearer quality of service and the charging ID that is applicable for this particular dedicated bearer. Okay, we got these details from P gateway to S gateway to um, MME. Of course, this S gateway's S1U tunnel details, uh, 4D7 and this IP address information, this must be sent to eNode B because eNode B requires this tunnel identity and IP address to send the uplink traffic to S gateway to send it. We needed this. So we have outbound. Um, we have the outbound NAS message here. Okay, so we have NAS security and integrity protection and ciphered part here. Okay, what are we going to have here? Um, so we are sending a NAS message to the mobile. What is it? It is a EPS session management message. What is it? Activate dedicated bearer request. We are sending it to the mobile. EPS bearer ID is 6 and quality of service is this much. Guaranteed bitrate and MBR finalized by your MME. And QCI value is 4. Quality of service class identifier is 4. And what is the uplink TFT that we want to suggest to the mobile? So whatever the traffic that goes to this particular application server must be sent on EPS bearer ID 6, that is the dedicated bearer. So this is the packet filtering criteria we are setting. So by setting this, we pack this information along with all the 3G specific quality of service parameters, and it is the best effort traffic, and we try to create uh, a dedicated bearer. But once the NAS message is prepared, we have to send the NAS message to the eNodeB, so that eNodeB can forward it to the mobile. So we have to use S1 AP services. But meanwhile, we received an inbound message notify answer for the notify request message you have sent earlier, a lot earlier. The reply is coming back here. We ignore the notify answer. Uh, After here, we skip it. So outbound. So we are packing the NAS message inside a S1 AP message in a message called as ERAP setup, initiating message, ERAP setup request we are sending. All right. So what do we have in ERAP setup? Asking the MME to create ERAP radio bearer plus S1 bearer. What details would be there inside? So we have yeah, a number of IEs that would be present are 3 MMU ES1 APID, and second one is ENODB ES1 APID, followed by the third one, that is ERAP to be set up list. So in the ERAP to be set up list, we have ERAP ID that need to be created is 6, and ERAP level quality of service parameters like QCI, allocation retention rate, guaranteed bit rate, etc., etc., followed by the transport layer address. This is the IP address of S gateway and a tunnel ID on the S gateway for this S1U uplink thing. Yes, dedicated bearers typically used only for particular application. It can be used by all the applications. Particular application that requires that quality of service. Okay, so we have the S gateway's IP address and tunnel ID details provided to eNodeB along with this NAS message. So what does eNodeB do with this NAS message is you will have to extract it and send it towards the UE. I did not create the call flow for dedicated. Let me create it and show you maybe in our next sessions. You can use it for correlating. But if you want to correlate right now, if you want to imagine, just imagine this. So we have P gateway, we have S gateway, we have MME, and we have E node B, and we have user equipment. So these five components which will be playing the crucial role. P gateway triggers create bearer request. S gateway sends the same message create bearer request to MME. MME triggers a message called ERAB setup request, creating a ERAB, asking them Enode B to create a ERAB, and Enode B send a message to mobile equipment called RRC connection reconfiguration request. It is the time you have to start bringing back your previous protocols knowledge. RRC connection reconfiguration request, and in this reconfiguration request, it asks the mobile equipment to create a dedicated bearer DRB, data radio bearer. It asks mobile to create. In that RRC connection reconfiguration request itself, we will include this NAS message asking for the permission to activate the dedicated bearer. First, mobile will send a response. RRC connection reconfiguration complete. It sends, and once the complete comes back, um, it Enode B sends ERAB setup successful response. It sends to MME. So MME need to now respond back to this create bearer request by sending a create bearer response. But before responding back, it will wait for mobile equipment's permission. So once mobile sends next a NAS message called as it is going to send a NAS message to Enode B. Enode B forwards that NAS message to MME. The NAS message is are accepting the activation of dedicated bearer. Once that arrives at MME, MME sends create bearer response back to S gateway. S gateway sends create bearer response to P gateway. So create bearer, request started the procedure, and it ended with create bearer response. But we have communicated with all the network elements because between mobile equipment to eNode B, we need to create a radio bearer. eNode B to S gateway, we need to create S1 bearer because they cannot directly communicate with each other. MME is coordinating the thing between them, and here between P gateway to S gateway, we are creating S5 and S8 bearer. But the number of steps that we have are these many. Starts with the create bearer request, ERAB setup request, and RRC connection request, RRC connection reconfiguration request, RRC connection reconfiguration response, and ERAB setup response. Then we wait for the mobile's permission to activate the dedicated bearer. That permission comes in the form of a NAS message. That NAS message would be sent in the form of uplink NAS transport. Once MME gets that permission, he decided to reply back to this create bearer request by sending create bearer response. That create bearer response goes to create bearer response goes to your P gateway. This is the um, procedure to correlate. Just remember this in your head right now. Okay. So we are sending the NAS PDU to the eNode B in this ERAB setup request. So what eNode B does? eNode B triggers RRC connection, which we cannot, RRC connection reconfiguration, which we cannot see. eNode B receives RRC connection reconfiguration complete, we cannot see. But once the complete arrives at eNode B sends a inbound message, inbound successful outcome for ERAB setup. So whatever ERAB setup request we have sent, for that it is sending a successful outcome. How many IEs are there? 3 IEs. MME UES1 APID, eNode B UES1 APID, followed by ERAB setup request that we have sent, and the reporting is for that. So we have ERAB setup list, which ERABs are successfully set up. So it is reporting back that ERAB ID 6 is successfully set up. And for this ERAB ID 6, IP address of eNode B and a tunnel ID of the eNode B. So there will be a separate tunnel ID for every bearer. For a default bearer, we use one tunnel. For a dedicated bearer, we use some other tunnel. So this is the dedicated bearer tunnel that got created on the eNode B. Even S-Gateway creates multiple tunnels for multiple bearers. So by taking these tunnel IDs, eNode B tunnel IDs, we have to respond back to S-Gateway and tell the S-Gateway that S-Gateway man, listen, this is the tunnel ID for you. Um, so we have to respond back. Okay, so but before responding back to Yes Gateway with this tunnel ID details, MME need to wait for the next message. What is it? There is another inbound message arriving from the S1 AP from the eNode B, that is uplink NAS transport. Now we know that mobile equipment have sent a NAS message to eNode B containing his acceptance for the dedicated bearer activation. That NAS message is packed into uplink NAS transport by eNode B and sending it to MME. So this uplink NAS transport, as usual, contain 5 IEs. First IE is MME UES1 API ID. Second one is eNode B UES1 API ID. And the third one is the NAS PDU we are having. So the NAS PDU, which is in encrypted format, followed by mobile's present cell ID and mobile's present tracking area ID. These details will always be present. But once we decrypt this NAS message, once we decode this NAS message, it is a EPS session management message, and this is linked to EPS bearer ID number 6, and the message is about activating dedicated bearer acceptance. So mobile has accepted the activation of dedicated bearer, which is proposed by MME. Creation is already completed. The radio bearer is created, S1 bearer is created as well. Of course, eNode B tunnel details are still needed to be forwarded to S gateway. S gateway tunnel details are needed to be forwarded to P gateway. The two steps did not happen yet. But once this permission comes from the mobile equipment, what does your S gateway do once this permission comes back? Um, First MME does the activity. So MME sends out a message, outbound message. Uh,